Hello friends, welcome back to C Field Academy. This is Suraj, and today we are going to discuss another sorting algorithm, which is merge sort. So this video is in continuation with series of videos we are doing for the popular sorting algorithms. So friends, let's get started. So these are the following topics we will discuss with merge sort. So first we will start with the introduction to sorting problem, and then we will start a little bit about the features of merge sort before we actually jump on to discussing the basic idea behind merge sort. So during the basic idea behind merge sort, we will just see the intuitive strategy behind how merge sort works, like the divide and conquer algorithm and how it is basically used. Then we will jump to merge sort algorithm. So basically the algorithm pseudocode in steps, and we will discuss that a little bit with some diagrams. So and once we discuss the algorithm, then we will move on and then try or apply the algorithm to a detailed example where we will see each step by step in details, in fact in very greater detail, so that our understanding on the merge sort is clear. Then as always we will go ahead with the performance analysis or the complexity analysis for merge sort, and finally we will end with an exercise for you guys to try it out. Basically, using merge sort you would need to sort a given array. So cool, let's get started with the introduction. So first of all, sorting problem. So what is a sorting problem? Now this is one of the very basic problems in computer science. Now I think you might already know how to sort books, say, or how to sort numbers. So in this example we'll just take, as for simplicity, we'll just take there are a bunch of numbers and we need to sort them. So let's say we have input as a sequence of n numbers numbered from a1 to an, and they are in a mixed order, and the problem or the required task is to order these numbers in ascending order, or in other words the output is a permutation or reordering of these numbers such that, and if the reordering is a1 dash a2 dash to an dash, in such a way that a1 dash is less than a2 dash and a2 dash is less than a3 dash, so on till an minus 1 dash is less than an dash. In simple words, we have a bunch of numbers and we just need to order them in ascending order. So that is the entire sorting problem. And as I already mentioned, this is one of the very important problems in terms of computer science algorithms and data structures. So this is most discussed problem, algorithms or data structure problems, especially at undergraduate level. So let's say we have an input sorted data. So this might be an array where we have about 9 elements, and you can see the numbers are unsorted. We have 3, 7, 4, 9 and so on, and our job is to apply an algorithm or apply some strategies, apply some steps, and then convert it to sorted data, which looks like this. So 1 2 3 4 5 6 7 8 9. Alright, so what is merge sort? So merge sort is a sorting algorithm that uses divide and conquer approach. Now if you have seen my other video on introduction to sorting algorithms, if you haven't, I would highly recommend you to see that. There I discuss some basics of sorting algorithm. We see and compare the sorting algorithms, popular sorting algorithms in detail, and we see the different approaches or approaches or strategies that we use to sort the bunch of numbers. So the first set of sorting algorithms, which we already discussed, were selection sort, bubble sort, and insertion sort. So they use the pass based strategy, which means we go through the input data a number of times, and then during that we sort the data one by one, steadily, slowly, and at the end of each pass we increase our sorted data by one. And the next set of strategy we discussed was the divide and conquer approach. We in fact discussed already a quick sort. There is a video on my channel if you want to look at it, that also uses divide and conquer. And merge sort also uses divide and conquer approach. So what happens in divide and conquer approach is the array is divided into smaller parts first, using some idea, using some strategy. In this case, in merge sort, we just divide randomly such that ensuring the partitions are of same length, and we keep doing that till we have very small size of partition, which means there is only one element in the partition. And then the next step is we repeatedly merge it. Now once we have divided it, then we merge them, and while merging we ensure that we are sorting the data in every step in the merge till we produce a final sorted list. So we'll see that in a bit. We'll see merge sort in detail. And another property of merge sort is recursive. Merge sort is it's actually not in place. In place merge sort do exist, but in this video we are not going to discuss in place. We will discuss merge sort where we need some additional space to actually sort the data. So this is mentioned wrong here. Normal merge sort, simple strategy merge sort doesn't do it in place, but it is stable. Now stable means we have, let's say, two keys with the same value, which means let's say we have two keys with same value. So if there are two keys with the same value, the original order that was in the input data still remains the same in the output order. So hence we say merge sort is stable, but as we discussed, it doesn't do it in place because we need some additional space to actually do the sorting. And it is also not online. So not online means it cannot work on streaming data. In fact, only sorting algorithm that works is insertion sort in the list of popular algorithms that we have. So if you want to know more about these properties, I would highly recommend to the introduction to sorting algorithms video, which I'll make sure to link it here, so that you can go ahead and look at these definitions in greater detail. So alright, cool. Let's see what is the basic strategy of merge sort, or the basic idea behind it. We already discussed that merge sort uses divide and conquer strategy, but what it does is in divide and conquer strategy. So what it does is we repeatedly divide the original array roughly into two equal partitions. Because the array may have odd or even elements, we just try to divide it into two equal partitions, and then we keep dividing the smaller partitions into again two partitions, and we keep doing that till we have each partition as a single element. So this is the first step. So let's say we have this array. We will first divide it into two parts, in this case 4 and 4. We had 8 elements, and then we will divide it into 2 and 2, and finally we will have 1 1 1 1. So each partition has one element. So in total we have 8 partitions in this case. Then once we have those partitions, what we do is we find adjacent partitions, which means we start from the first two ones, and then we merge the two partitions by comparing the two elements and then maintaining their order. So let's say let's say this is 3 and 2, and I have to merge this partition. What we will do is during merging we will make sure that the numbers are in order. We'll compare it, and then we will change this to 2 and 3 so as to order the elements. Similarly, we will keep doing with the other adjacent partitions, and then we will get a partition of size 2. Then we will merge 2 with 2 to get a partition size of 4, and we keep doing that till we reach the end of our which means till we get our own the size of original array. So we just repeat the merge process with adjacent partitions, then from 2 to 4, 4 to 8, and finally we will get the final sorted array. And while merging, so the strategy here is while merging we have to make sure that the numbers are in order. Alright, now let's see the pseudocode or the algorithm steps in detail and try to understand it. So here is the pseudocode for merge sort algorithm. So as we already discussed, it's a recursive algorithm, which means merge sort actually calls merge sort again. And if you notice, what happens is the size of the array is reduced. So initially we have merge sort A, there is a low and high which points to the starting and the end point of the array. So something like this, low and high point to the starting and end point. And then what we do is we partition the array roughly into two equal parts and then merge the two parts. Hence the first step to check is if the array has at least one element or at least two elements, because then only we need to actually partition it. In fact, yeah, till low is actually less than high, we just keep partitioning the partitioning the array, which means if low is less than high, so which means the array has at least two elements, then only low will be less than high. What we do is first we calculate p. P is an intermediate variable that points to low plus high by 2, which means to the midpoint of the array, something like this. And once we found p, what we do is we just call merge sort on the left part of the array and then on the right part of the array. That's why you see the first parameter in the first merge sort is low, the second parameter is p, which means we pass the left side of the array, so something like this. So this is again passed to merge sort. So merge sort will be applied on this array and then merge sort will also applied on this array. So that is the basic strategy. First we find the midpoint. So this is what happens: merge sort a low p and merge sort a p plus 1 high. And then because it's a recursive algorithm, this will keep continuing and calling with low and high values getting changed. So low and high values will get reduced, and finally this recursion will end when low is less than high, which means when the array has one element, then this if condition will fail. So there will be no more merge sort call. But then what needs to be done is once the merge sort is called, we now will now have two partitions, and those two partitions will be merged using a separate procedure called as merge. This merge we will see what it contains. And notice what merge takes. It takes a, it takes the low and high which was originally present, and the midpoint of the array p. So basically the merge point at which the algorithm needs to do the merge. Alright, so now let's now see what merge does. So this is what it does, and let's now see what merge does. Now what merge does is merges two parts of the array by comparing the head of both the parts and copying the smaller of them, and it repeats the same process. So the first step, now this is where we need additional space. So what happens is in the merge procedure call, even though we have the original array A, we will need additional that much of space to be able to do the merge, and that is what the first part of the merge does. So the first step is it initializes two variables, n1 and n2. Now n1 is the size of the leftmost array, which is p minus low plus 1. N2 is the size of the rightmost array. Then it initializes two arrays, a1 and a2, which are two temporary spaces, and it copies the elements from the original array from the start to the midpoint to a1, and it copies all the elements from the array a, the second half of the array, to a2. So this is the first step. Now this is why additional space is needed. So let's say we have a1 which is of size n1 and a2 which is of size n2. So the first step is to, if we had the original array over here, which is like this. So, and let's say P was the midpoint somewhere here. What we do is we copy all this data over here and the remaining part of the data over here, A2. This is the first step. Now once we do that, the next step is to merge these two arrays, A1 and A2, into the original array which we had. So this is AN, which was the original array we had, where we need to put our sorted elements. So A1 and A2 will be merged and then they will be sorted and put in AN. So that is the simple strategy. So let's see how that is done. I'll just rub this for a minute, change my pointer to pen. And so first what we do is we initialize three variables I, j, k that point to these arrays. So A1 has I, A2 has j, and AN has k. Now AN needs to have the sorted elements. So here is the pseudocode. So the first step what we do is step 6 to step 9. What it does is we have these pointers I equal to 1 and j equal to 1. We first compare the elements that are pointed by AI and AJ, and we see which is the minimum element. Now that minimum element is copied to the space pointed by k. So let's say I was 1, j was 1, we found something, we compared, and then the minimum element we copied to k. Now whichever element was copied, if it was from A1, then we move that pointer, so we increment that pointer I. Let's say if we copied from I, we increment the pointer I, and then we again compare the values of AI and AJ, and then find the minimum and again replace the next value at k. So this is the general strategy. So that is what we are doing. So we are doing till when, while I is less than n1 and j is less than n2. It means till both these array have some elements. So I hasn't reached n1 and j hasn't reached n2, which means there are elements to be compared in both the arrays. What we do is we compare a1i with a2j, which means head of the element pointed by I and head of the element pointed by j, and we see which one is minimum. If ai is minimum, then we compare ak, which then we copy a1i to ak, and then we increment I. Otherwise, if the element at j is smaller, then we copy that element to ak and we increment the j, and finally we increment the k, so that k now points to the next location. So we keep doing that. So this is the general idea. Let's say we increment and then we keep copying the element, and at some point, let's say k reaches here and I reaches here, and let's say j reaches at the end. So this array is now done. So there are no more elements to be compared from I to j. So then what happens is, after we compare the last element and then move, because the A2 array is done, we still have some extra elements in N1 or in A1. So those extra elements now no need to be compared. We just move those elements directly to the end of AN. So this might happen with A1 and A2. This example shows as A1. But what we do is, here in step 10 and 11, let's go to the algorithm now. Now what we see is the while loop, the previous while loop will end when at least one of them, either I or j, has reached the end of the array. Once we have reached the end of the array, we are now done with that while loop. But what we need to do, we need to check which array has remaining elements, extra elements, and then we copy those elements. So that's why what we do is we check while I is less than n1. So which means if there are extra elements left in a1, we just keep copying them, ak equal to a1i, increment both I and j, and we keep doing that till our array a1 is complete. Or what we do is, let's say if array a1 was completed but there are extra elements in a2, so it will come to this while loop while j is less than n2, and it will copy the elements from a2 to ak and increment k. So finally, at the end of all these steps, what we have is we have merged elements from both these arrays, and the elements are now in sorted order. So that's the output of this merge operation. Alright, cool. So let's just go back for a minute to our merge sort algorithm and see what happens. So there are only 3 steps in this algorithm. We check if there are elements left in the array. What we do is we call recursively merge sort, merge sort. Once we have the elements from the merge sort, we then call the merge procedure to merge the elements, and then finally we have the sorted array. So that's how it looks like. Alright, so now let's go ahead and let's now go ahead and apply this algorithm to a real example, so that the understanding would be much more clear. In fact, we will go into very greater detail into this example. So let's say we are given this array with 9 elements, 9, 2, 7, 4, 6, 11, 3, 5, 10. I think it's the same array we have been using in all our sorting videos, almost the same array. So the first step is to call merge sort. Now remember, this is a recursive algorithm, so we need to make a call, and during the call we need to pass the starting and the end point of the array. So the starting point, that is low, is 1, and high is length a, which is n, or which is the size of the array. So in this case this will be 9, because we have 9 elements in the array. Now let's apply it. Now here is the merge sort algorithm again, which we discussed. Now let's apply it to this array. Now, as we already discussed, low will be 1 and high will be 9, because we have 9 elements in the array. So we'll go to step 1. So in step 1, what we check is low is less than high. In fact, low is pointing to 1, high is pointing to 10. Yes, low is less than high because we have 9 elements in the array. So then we have to go, and the first step or the second step here is to find p, which is the midpoint. Now midpoint is low plus high by 2, which in our case is 1 plus 9, 10 by 2, which is 5. So p will be 5, and it will point to the 5th element in the array, which is 6. Now once we have, then we go to step 3. Now in step 3, what happens is we call merge sort with a low p. Now note p is 5, low is 1, so p is 5 and high is 9. So the first step is to call merge sort with a low p, which means a1 5. So this will be the first step. The first step, what it does is it reduces the size of the array, which means we call merge sort again with the left half of the array, and then step 4 calls merge sort with the right half of the array, which means 6 and 9. So we have merge sort a, 6 and 9, and then finally we have merge a low p high, which we will discuss later. Because this merge sort 1 5, what will happen is, now merge sort 1 5 will call, it's a recursive call made to the merge sort. So what this will call is, it will pass low as 1 and high as 5 to the algorithm again. And once 5 and 1 and 5 is called, so which means the left half of the array is created, we again call we again check for low is less than high. Now in this case 1 and 5, 1 is definitely less than 5, so due to which it will go to step 2 again, and it will have low equals to high plus 2. Now in this case 1 plus 5 by 2, 1 plus 5 is 6, 6 by 2 is 3. So new value of p is 3, so it will update the new value of p is 3. And similarly on the other end, the other part of the array where we have 11, 5, 3, 10, now there what will happen is we will have low and high. There we will have low as 6 and high as 10. So in this case we'll still have low is less than high, so 6 plus 10 is 6 plus 10 is 16, which means p in this case will be 8. So in the second part of the array we will have p equals to 7, sorry, p equals to this is 9, I'm sorry, so this is 9 here, so 6 plus 9 is 15, 15 by 2 is 7, roughly 7.5, and it will be rounded to 7, and that's why P is 7. So which means in the next part of the array will again be divided into two parts with P equals to 7. So what this will yield up in is in 9 to 7 smaller subarray, 4 6 as the next subarray for the left part, and for the right part we have 11 3 and 5 10. And in fact merge sort will again be called on it recursively, and it will again try to find the P, which is the midpoint, which in first partition is 2, the next partition is 4, next is 6, next is 8. If you want to calculate, you can calculate using low and high, and we keep doing that till what happens is we are till each partition is left with single element. Now if 9 to 7 will be divided at 9 2 and 7 because P was 2, and in this case 4 6 will be divided into 4 and 6, 11 and 3, 5 and 10. Alright, now in the first subarray, which is 9 and 2, we have P equals to 1 because this is 1 plus 2 3, 3 by 2 is 1, so this will again be divided into 9 and 2. And then when we reach 7, now for 7 what will happen is, because this is the only element, low and high will point to the same element. So in this case low and high will point to 3, so the if condition will fail, so which means there is no longer further calls to merge sort, so which means this merge sort method will now return, so there is no more partitions to be done. In fact the same case will happen with 4, the same case will happen with 6, 11, 3, 5 and 10, because these are single elements. Low and high will point to the same value, and they will no longer to be recursively merge sort. There is no longer need to call merge sort, and they will return. And then what will happen is, once they return, so let's say 4 and 6 returns, then how will it look like? Let's see how will it look like. So at this step, so at step 3 we will return, we'll have single array here, in this case 4, in this case let's say we have 6, they have single element. Then the method merge is called on low P and high, so which means for 4 and 6 we will call merge A 4, 4 and 5. Why? Because in this case low was 4, P was 4, if you notice before P was 4, and high, which is 5. So the merge method will be called merge A445, which essentially means we need to merge these two elements and then form an array of size 2. Alright, cool. Similar thing will happen with 11 and 3. Merge A667 will be called, because notice P is 6 here and 6 here, and left low and high are 6 and 7. Similarly we'll have merge A889 will be called with 5 and 10, and finally with 9 and 2 also merge A112 will be called. So these are the merge procedure calls that will happen, and let's now go ahead and see how these merge methods are called and what is the output of the merge. Alright, so here is the merge procedure which we already saw, and essentially the whole purpose is to just merge the two parts of the array and result in a sorted array. So let's first start with A445, which we had. So in this case we actually have A as 4 and 6, only two elements. Low points to 4, high points to 5, and P is 4. So this is what A46 means. So this means we have two partitions, each of size 1, 4 and 6, and we need to merge it and then place it back to A. So let's see. So the first step, as we discussed, is to have A1 and A2, which means we have two arrays, temporary arrays, and copy the elements from the first part of A and the second part of A2, A1 and A2. So this is the first step. We have A1. In this case, the size of both the partitions are 1, which means N2 is 1, N1 is 1. If you put these values, we'll get as 1. P minus low, let's say 4. Low is 4, 4 minus 4 plus 1, so it is 1. High minus P is 5 minus 4 is 1. So actually both the elements are of size 1. So that's why we have A1 is of 1 and A2 is of 1. And the first step, as we discussed in step 1 to 4, is to just copy the values. So we copy 4 and then we'll have A1 with 4, we copy 6 and then we will have A2 with 6. So this is the first step. Then the second step is the merging part, which starts from step 5 to 9 in the first phase and then 10 to 11 in the second phase. So in the first phase, what we do is we have a pointer I, J and K, which points to the first elements of the array. So I points to I is 1 and it points to the first element, J is 1, it points to the first element. In fact, in this case we only have one element, and then the original array A, which was there, which had 2 elements, and we have K at 1. So we come to the first while loop. Now there we check I is less than N1 and J is less than N2. Notice both are 1, and in fact I is also 1, J is also 1, so while condition will succeed. And we go inside to step 7, where we compare A1I and A2J if A1I is less than A2J. Now see what happens. 4 is less than 6. Hence what we do is we will go to the first if condition, we copy AK equals to AI, which means we just copy the smaller element of the two, 4, to the first element. So we copy 4 and then now AK points to 4, and what we do is we increment I plus 1 and then we'll go to step 9 and increment K plus 1. So this is what we do. We increment I now becomes 2 from 1 and K also becomes 2 in step 9. Now we go back to the while loop again, and what we compare I with N1 and J with N2. Now I is 2 now, 2 is not less than 1. So that's why the while loop will end here, because I is done. So which means the left sub array is done. There are no more elements in the left sub array to be compared, and hence we will end the first while loop, and then we'll go to the next part of while loop. Now what the next part of while loop does is, now whichever elements are remaining, now those needs to be copied. The first one is I is less than N1. In fact, I is not less than N1, so this while loop will not be executed. But in step 11, J is less than N2. It is, because J is 1 and N2 is 1. So which means we just copy the remaining elements from the second part of the array to A. So in this case we will just copy 6 to the array A, and we have A4 6, and then our merge procedure ends here. So what we will have is, at the end, I will be 2, J will be 2 and K will point to 3, and we are now done with the merge. Notice, so essentially what we did is we just merged 2 arrays of size 1 to one array of size 2. Nothing much happened because they were already sorted, and then we finally return this array back. So this is what happens with A445. Now let's see the next part, which is A667. They are quite similar because these are just smaller arrays of size 1. So A667 has 2 elements of 11 and 3 which need to be sorted. So the first part, as we discussed, which is from 1 to 4, is to take 2 sub arrays. Now in this case also, if we calculate, N1 will be 1, N2 will be 1. It's essentially the size of the partition. And what happens is, low is 6, high is 7 and P is 6. We have an A1 and A2 of size 1, and we just copy the elements as we did in step 1 to 4. Then we have the original array A, and we have the 3 pointers. I points to A1, J points to A2, and we have K points to A, where we need to compare and copy the elements. So we'll go to step 6, where we will have I less than N1, N1 and N2 are 1, I and J are 1. So this loop condition will be executed. So we'll go inside, and then the first step is to compare A1I with A2J. So let's see what happens. 11 is greater than 3. Now notice here 11 is greater than 3, which means the else part will be executed, and we need to copy the first element from a to j to k and increment j. So in this case what will happen is 3 will get copied, so we just copy the smaller element to the first uh, uh, place in our original array. So 3 will be copied. Once 3 is copied, we'll go to steps 9. So essentially j will be incremented and k will be incremented. So this is how it will look. So j will now become 2 and k will also become 2. Now we'll come back again to step 6, where the while condition needs to be executed. Now notice what will happen here. J has become 2, so this while loop execution will stop, because we have j which is now 2. In other words, the right part of the array is now done. We have no more elements on the right part of the array to be compared. And then we will come to step 10 and 11, where we need to copy the extra elements wherever they are present. So it will come to step 1 and will check I is less than n1, which is true. 1 is less than n1, which means we have one extra element on the left side, and we'll just copy that extra element 11. And finally this while loop will also end, and we will come to step 11, where we check j is less than n2, j is not less than n2, j is 2, which means there are no extra elements in the j array, right side of the array. So finally what happens is we have sorted the elements into 3 and 11. Notice what happened, they are now in ascending order, and then we increment ij and k, and we are done with the merge procedure, and we return. Okay, cool. We discussed two merge procedures. Now let's go ahead and do the next few merges. I think we have 3 more or 2 more at least to merge, and we will now go a little quicker. So the first one is A889. Similarly, we have 5 and 10 here. Low points to 8, high points to 9, and p points to 6, and n1 and n2 will be still 1 here, because the smaller partitions are still of size 1, and the resultant will be nothing but it will just be sorted array, which in this case is just 5 and 10, and we will just return. I mean, I have skipped the intermediate steps. You can, if you want to, you can definitely go ahead and try that out. Similarly, we have A112. A112 had 9 and 2, and what will happen is the end result of the merge, so low is pointing to 1, high is pointing to 2, p is 1, and the end result will be 2 and 9, and this will be returned. So finally we have made all 4 merge calls, and now let's go back and see the original merge sort algorithm, what we have achieved and what is remaining. So here is the original merge sort. So this is how we had, and now we were, if you remember, we were merging those individual single element arrays into 2. So if you remember, we had merged A445 here. Now A445 resulted in 4 and 6, A667 resulted in 3 and 11, and merge A889 resulted in 5 and 10. Similarly, we also had merge A112, and it resulted in 2 and 9. So essentially those single elements have now been merged into 2 elements, and the values are now sorted. So the next step is to now merge the two elements into 4. Now let's see what happens here. Now the first case is where p equals 2 in here. Now this single element 7 has not yet been merged. Now in this case, where p is 2, what will happen is we have high, low, and p. So which means merge sort here, the first merge sort will result in 2 and 9, the next merge sort will result in 7, and then the merge a low high will be triggered, which means merge a1 2 3. So with the middle element 3, merge a1 2 3 will be triggered in this case. So in this case we have to merge 2 arrays, one is of size 2 and other is of size 1. So, and then we will return back. Similarly, what will happen is, now in this case 4 and 6 will have to wait, because they have to get merged with the left part, which is not yet ready. In fact, normally it is ready, but because I am explaining it step by step, That's why I have just put it as wait, which means we will not merge it yet. They will have to wait because they have to merge to the left part of the subarray. So essentially what will happen in this case is basically p equals to 3. So merge operation will be called on this array, merge sort will be called on this array. So in this case merge sort from this would return in has to still return back, and this merge sort has now returned 4 and 6. So this merge has yet to be returned. Only once this merge will return, then we can do the merge over here, over the final final two partitions. So that is why I have written here wait, which means we will get to it in the next step. But on the right side, what happens is the right part of the subarray where there were 4 elements, we already have values returned as 311 and 510. So in the merge call for 11, 3, 5, 10, where p was 7, let me just point the arrow here. So this is the call. We have merge a low p, which is 3 and 11 returned, and a p1 minus 1 high, which is 5 and 10. And then what we do is we have to do the merge call with a low p high, so which is merge a 6, 7, 9. So essentially we have to merge these arrays of size 2 into array of size 4 that is remaining. So let's now go ahead and see these merge operations. Now the first is a1, 2, 3. This is a simple one, similar to what we had on single element arrays. Now in this case the only difference is low is 1, high is 3, but p will be 2. So which means the first array here n1 is p minus low plus 1. So it's 2 minus 1 plus 1, which is 2. So n1 is of size 2, but n2 is of size 1. So n1 equals to 2 and n2 equals to 1. So which means the left part of the subarray has 2 elements and the right part has 1 element. So in the first few steps, that is from step 2 to 4, is just copying. So we will create a1 array of size 2, a2 array of size 1, and then we just copy elements over. So a1 has 2 and 9 and a2 has 2. And then the next part of the array, next part is where we actually do the comparison and then copy the elements. So in this case we have a and we have ij and k pointing to the first element, and the first step is to compare 2 and 7, the head of the array. Now in both these cases I is 1 here, j is 1 here, n1 is 2, n2 is 1. So this condition will succeed, which means we'll go inside and then we'll compare ai with aj, which is 2 with 7. In fact 2 is less than 7, and hence this code will be executed, I code, which means it will copy the first element 2, and then it will increment j equals to 1, sorry, I equals to 1 over here, and then it will go to step 9 and increment k equals to 1. So sorry, k equals to 2. So k becomes 2 now, I becomes 2 now, and j stays still at 1. And now we have the now we again go to step 6 where we compare. So I is 2, so which means we are still there, we are still okay. So I is less than n1 and j is less than n2, which means we still have elements in both the arrays. And then we copy the head of both the arrays. So in this case 9 and 7, in fact 9 is greater than 7, so which means we need to copy the element from the j array this time. So the else part of the code gets executed. So 7 gets copied, and once 7 gets copied, what we do is we increment j, so j now becomes 2, and we increment k, k now becomes 3. Now we go back to step 6 again. Now in step 6 what happens is, notice this condition will fail because I is still at 2, but j has also become 2 and j is no longer less than 2. So what will happen is this while condition will fail, and in fact we will come to the next set of while conditions where what we do is we just copy the extra element that is remaining in the array. So in this case I is less than equal to n1, which is true, 2 and 2, and hence we will copy the extra element, that is 9, to the remaining part of the array. And once we are done there, we are actually done, because notice the second while loop will not work. J is 2 and n2 is 1, which means there are no extra elements in the J array. So once we have done that, we now have 2, 7 and 9. In other words, we have just sorted the array of 3 elements into its original place, and then we finally return 2, 7 and 9. So this is the result of A 1, 2, 3. Now similarly we have A 6, 7, 9. So this is the right side of the original array. Now in this case we have 2 and 2 elements in each partition. So low is 6, high is 9 and P is 7. Now in this case what will happen is N1, if we calculate the value, N1 will become 2 and N2 will become 2. So which means essentially we have 2 sub arrays of size 2 that needs to be merged. So the first step is to have A1 and A2 of size 2, 2, and then just copy the elements. So the first step is to copy 3, 11, and then copy 5 and 10. So that is the first step. And then what we do is we have our original array A, and now there is a problem here. This should be of size 4 because we have originally 4 elements up here. So the first step, or the first set of the array steps, is to just compare the head of each of these array, which means I, J and K, and keep copying the smaller elements and then keep moving the pointers. So in this case we have 3 and 5. 3 is less than, so we will copy 3, and then what happens is we will increment I. So I will now point to 11 over here, and then what will happen is notice J11 is still less than 5, so which means 5 will be copied here, and then similarly we will proceed. Next J will get incremented here, then we will have 10 and 11, so 10 is the smallest, we will copy 10 here, and finally once 10 is done, only 11 element is remaining, we just copy here. So we keep doing that. I have skipped those steps here, and then finally what we'll have is we'll have a 4 element array of which is sorted 3, 5, 10, 11. Now that will be returned back. Alright, cool. Now let's go back to our original merge sort procedure or merge sort algorithm. So this is how it will look like. So we first had merge A1, 2, 3 on the left side, which was to be done, which was a merge of 2 elements and single elements. So that will return 2, 7 and 9. And the right side, which we had A6, 7, 9, which was a merge of 2 and 2 sub elements, which will return 3, 5, 10, 11. So notice they are now sorted. So the sub arrays are now sorted. So then the first step will be, so the first part that is left is here, where merge sort on the left side needs to be called with P equals to 3. So this is the first merge sort that was called, that returned. This is the second merge sort, and now we need to call merge on this entire array, which is merge A135, to do the merge, and the right part of the subarray will wait till we get the results from the left part of the array. Alright, now let's see A135, merge A135. Now similarly merge A135, this has 5 elements, which means we have 3 on the left side and 2 on the right side. P points to 3, P is 3. So if we calculate, in this case we will have N1 as 3 elements and N2 as 2 elements if we put those values there. So the first step is to just initialize temporary arrays A1 and A2 and then copy the elements. So once we have the temporary arrays A1 and A2 and then we copy the elements, we'll have 2, 7, 9 and 9, 4 and 6. There is something missed here. I'll just add 9 here, 2, 7, 9, and we will then have the original array A. The next set of steps, which is 5 to 9, is to basically compare the pointers I, J and K and then copy the smaller elements to A. So in this case the first is 2 and 4, so 2 and 4 will be compared, and then we will just copy the smaller element, that is 2. Next what will happen is I will get incremented. I will point to 7, and j will point to 1, 7 and 4, so 4 is the next smaller element which will be copied. J will now move to the next value, then 6 and 7 will be compared, and then 6 will be copied, and finally the remaining elements, which is using step 10 and 11, which is 9, will get copied over here. So this will result in sorry, I think this should have 5 elements over here. So this is 2, 4, 6. We have to copy the 2 elements. 9 will be copied here, the remaining 2 elements, 7 over here and 9 over here. So finally we have 5 elements here, 2, 4, 6, 7, 9. That is the end result of this merge. Alright, so this will be returned. So let's go back to our original merge sort where we had A135 that would return in an array of size 5, which is sorted 2, 4, 6, 7, 9. Now the last part that is remaining is to merge these two arrays, A159. Now this is the left return, this is the right return, and this is the original call. So we are left with this call, which is merge A159. That is a merge of two subarrays, one of size 5 and the other of size 4. So let's now go ahead and see this one in detail, because this is the longest one. We will try to cover it step by step. So we have merge A159. So this was the array, and we have low pointing to 1, high pointing to 9, P is pointing to 5. The first step is to initialize. First step over here from A1 to 4 is to initialize N1 and N2. So N1 in this case will be 5 because P is 5, low is 1, and this will result in N1 being 5, N2 being 9 minus 5, which is 4. So we will have N1 as 5 and N2 as 4. So the left part of the array and right part of the array. And the first step is from step 2 to 4 is to just copy these values. So we'll have 2, 4, 6, 7, 9 copied onto A1 and 3, 5, 10, 11 copied to A2. Now let's go ahead and execute the next part, which is step 6 to 9, which means copy the head, compare the head of these three, compare the head of A1 and A2 and copy the smallest element. So first step is I will be 1, J will be 1, and we start with K equals to 1 also. The first step is 2 will be less than 3 compared, and then 2 will be copied. Then what will happen is I will now become 2 because I was 1 earlier and we copied the element, and K will also become 2 because K equals to K plus 1. The next step is to compare 4 and 3, and 4 is greater than 3, hence 3 will be copied, which means the element from A2 needs to be copied, and 3 gets copied to the array, and J now increments to 2, K now increments to 3, and we'll again copy the head of both the arrays 4 and 5. This time 4 is lesser, so we'll copy the element from A1 4, and we will then move ahead with I equals to 3 and K equals to 4. Now if we copy, we will see that 5 is less than 6, which means we need to copy the array from copy the element from A2 array. So we copy 5, and then we have 2, 3, 4, 5. Next, in this case, we'll increment J because J was 2, J becomes 3. I was 3 earlier, I is 3, and K is also incremented to 5 now, the fifth element. We'll compare 6 with 10. 6 is less than 10, and hence A1 6 will be copied, and I will be incremented to 4. J will still remain at 3, K will become 6 now, and we'll compare both the elements, which is 7 and 10, and in this case 7 is smaller, so we'll copy from A1 and I will be incremented to 5. So J now becomes 3 here. This is some problem here. J is actually pointing to 10, I become points to 5, and we'll compare K now becomes 7. We'll compare 9 and 10 over here, and 9 is smaller, and hence A1 will be copied. And then what will happen is I will now become 6. In fact, if we notice the left part of the array, we are done. There are no more elements in A1 to be compared. So what we just need to do now is to just compare the remaining elements from A2. just compare, these are the remaining elements, we just copy 10 and 11. First step, we'll stop comparison, and then we'll copy 10 first, and then finally we'll copy 11. And once we are done with copying 11, we will end with all the while loops, and this is the final array which will now be returned. So, and notice the final array is now the sorted array. In fact, once we merge the smaller two subarrays, one of size 5, other of size 4, we get the final subarray that will be returned as a result to the merge sort call. Alright, cool. So I hope all these explanations helped. It was probably a bit lengthy, but I am assuming they would really help to deeper the understanding of how merge sort works. Okay, so now let's go on and do performance analysis, which means let's do a complexity analysis for the merge sort algorithm. Now notice what we had. We actually had two procedures. The first one was the merge sort, and then the merge call that was embedded or inside it. So let's first see the merge call and how it looks like in terms of complexity. So if you remember, the first part of the merge involved just copying the arrays, copying the values from the original array A to sub arrays A1 and A2. And they were exactly copying almost half the elements. So the first one actually copies n1 elements, and the second one is n2 elements, and in fact n1 and n2 were almost same, or they would just vary by 1. And then there were some steps, assignments, and then we had a while loop which ran for n1 while I less than n1 and j less than n2 times. So this will run whichever is greater. It's not n1 plus is to n2, but it will run max of n1 and n2, minimum, whichever was smaller of n1 and n2. So it runs that many times, the first while loop, where we compare the head of the elements, and where we compare the head of both the arrays, and then we copy the smaller element. So, and then we had the next while loop which ran about n1 times if I is less than n1, and then n2 times there was a j array if j started from 0, but actually j doesn't start from 0. So what happens is, the first two for loops which we had, so they were doing n1 plus n2 comparisons, or n1 plus n2 swaps, which essentially is just the total size of A, which means it's n, high minus low plus 1, which is just order of n. Now the next while loop, what they essentially do is they start from the starting of the smaller arrays, and then they will copy the minimum element of the array till one of the arrays is done. So the first while loop actually runs minimum of n1 and n2 times, whereas the extra elements that are there, which is either one of these while loop, both these while loops never do any work. It's only one of them does the work, because one of them would have reached either I would have reached n1 or j would have reached n2. So in short, what happens is, the number of comparisons that is made, it's just n1 plus n2. So n1 the smaller array, n2 is the next array. It's just how we do it is different, and that's why we ended up having 3 while loops. So in total we only do order of n, which means we are essentially just comparing the elements just once we go through the entire array. So this is also order n, and hence the total comparison here is just n plus n 2n, and 2n, if you guys remember how the complexity works, is it's just order of n, because n is pretty large. So it's linear in n, it's not quadratic, it's simply linear in n, even though it's 2n. Okay, cool. Now let's come to the original merge sort algorithm. Now original merge sort algorithm, what it does is, it's a recursive algorithm, and hence recursive algorithm merge sort, it calls first part of the merge sort is, it just divides the array into 2 parts, and calls the merge sort with n by 2 size, and the next one is also n by 2 size. This is approximate, sometimes it may be odd and even, but it just makes a call to the same algorithm with after halving the size of the array. And finally it calls the merge. Now we have already seen the complexity of merge is order of n. It was 2 times it had 2 passes over the array, but the complexity is n. And let's now compute the complexity of the entire merge sort. So entire merge sort, because this is a recursive algorithm, we can write a recurrence equation. In this case it's Tn equals to Tn by 2 plus Tn by 2 plus order n, which means the original problem is divided into 2 problems of half the size, because n by 2 is now the new size of the new size that is passed to the merge sort. And then finally this order n, this comes from the merge operation. So if we solve it, we will actually have 2Tn by 2 plus order n. Now which, if we go ahead and solve by substitution or by using the the algorithm that we have, Master's theorem, if we apply, we will get its order of n log n. So this is the total time complexity of the merge sort call. And if you have noticed, it really doesn't matter the best case, average case, or the worst case. In fact, in all the 3 cases, merge sort always performs the same: n log n, n log n, and n log n. The total number of comparison and merges is actually independent of the pattern of the data, and that's why that's one of the quality of merge sort. Whatever is the distribution of the data, even if the data is originally sorted, we still have to divide it into sub arrays and then merge it to the entire sub array. And that's why merge sort performs in order log n in all the cases: best case, average case, and worst case. Alright, so we saw that the complexity of merge sort algorithm is order n log n. And I think that's all I have for you guys in this video for merge sort. And before we end, here is an exercise for you guys to try. So use merge sort and sort the given arrays. List the total number of recursive calls made to merge sort. So when we do the recursive calls, if you remember the table that we saw, make a table similar to that and see how many calls we are making to merge sort. And in each of those calls to merge sort, and in each of those calls to merge, see and find out the total number of comparisons that were needed during the merge operation, and list them also. And here is the array. The array has 10 elements. If you need, you might want to just go back to the video and see the steps over again, or the algorithm over again. But yeah, this is the problem, and make sure you solve it and then post any comments or any issues you had solving it. If you have the solution, you can post it on this video and I'll definitely reply to it. So we have now reached the end of the video. Thanks guys for watching. If you have any comments or suggestions, make sure to put it in the video and I'll definitely attend to it. Thank you guys. See you again in the next video. Bye bye.